All right, so last time we were looking at this program right here, and remember how I made that statement, like sometimes you just need to take a walk? Well, certainly I figured out the bug the moment I sat back down in my office and looked at it. So I'm glad my mind caught that cue to say go ahead and solve this while I was busy with other stuff. So again, just as you program, you should always kind of think about, like, as things are doing something unexpected, why is that the case? So this one's a little bit short. So again, if you're thinking about, okay, why did it not quite finish this circle, especially for a large one, it probably had something to do with rounding, didn't it? Like it always rounded down, right? So that's kind of the thought I had when I came back. And again, maybe you guys didn't know this. I've just had, of course, more exposure to different languages and to just the different iterations of Python. And I believe I mentioned this last class, but Replit version of Turtle module is actually from Python 2. The one thing that may be a good way to tell you or notice this, if you're ever looking at other Python code and not sure if it's in the more modern version of Python, is to do print and try and print this. If you try to do this in Python 3, it's going to throw up an error because what happened from Python 2 to 3, in Python 2, there were two prints. There was the print that was a function, which is what we have in Python 3, but there was also a keyword print, which handled a similar way. So you can see right here. Now, if I were to run this, and you can see in the console down here, it still does print. If you were to do that same thing, it would say like, "Hey, I don't know what's going on," or throw a syntax error in Python 3. So a good quick way to tell if a code is written for Python 3 or Python 2 is to find a print statement. Now, with that in mind, the behavior of division changed from Python 2 to 3. And do you know how if we divide, it automatically casts the result of a division to an integer? Or excuse me, casts it to a float? That is not implicitly done in Python 2. You have to go ahead, and if you want division to give you a float, you have to either cast it or do something very simple. Put a dot by a integer, and if you ever divide with that integer, it'll automatically cast it. So notice I go back up here, line 4, and put degrees in circle. I put dot, or maybe just to make it clear, 0.0, and now if I do this, it will go ahead and draw the whole circle. So it's amazing how one little bug is from a period. And again, I didn't expect y'all to know that, but hopefully you guys were thinking like, or at least sat down to think like, why is it behaving this way? So the deeper you think about the program and why certain things are happening, the better understanding you will have. So with that being said, we have now resolved that. So go ahead and just make sure that when you fix that little thing, that little dot or the decimal point, it resolves itself. Okay, so I actually have another exercise that we can go ahead and look at. We're going to go ahead and do this one together because I want to do three things today. I want to just go ahead and talk about an idea in programming known as refactoring. Then I want to go ahead and talk about something known as scope. And then we're going to go ahead and preview the project. Has anyone had a chance to look at the code? Now, if you haven't, now let me tell you, this one, will require much more time than the first one because you're going to have to analyze the code that's there. And there's just more structure to it. Before, if you think about our first project, it was just operations, grabbing some input. This one, you have some algorithms. You have basically 4 different algorithms to implement, and then part 5 is going to actually ask you to modify some of the starter code in order to meet a certain expectation. So, and by the way, let me just remind you again, when it comes to working together, don't show code to each other. It kind of ruins the learning experience for you, which will eventually harm you in the long run when it comes to the midterm, the final, and just as we get into larger programs. But feel free to discuss things at a high level, like whiteboard or work on a piece of paper. But it's one of those things. Don't harm yourself by not putting in the time. Okay, so the next exercise what I want to do is if you think about what we've done, like, and we kind of ran into it when we had that bug in our code, it would be nice if we can draw just portions of a circle. So our next exercise is basically to write a more general function than circle called arc. So let's go ahead and write a function called arc. Let's define it. And what our goal here is to define a function called arc that has two formal parameters. It needs to take in some turtle, t, and some radius, r, and it also is going to be some angle of how much angle we want to go ahead and draw of the arc. So if you think about it, it's pretty close to what we did up above here. We're going to have to make a couple changes. So if you think about an arc, we need to make a change to a circumference. So we're still going to need some circumference, but we're not going to want all of it. So we're going to have 2 times pi times r. But if we want just a portion of it, what are we going to need to multiply by? Well, how much angle we have out of 360. So we're going to have to multiply it by the angle out of 360, which we can go ahead and use that degrees in circle again to just kind of not use any sort of magic numbers. The n, again, we talked about this at the end of last class, and I just want to go ahead and maybe talk about this a little bit again. So again, our goal was to not hard code n, and if we were to do circle, we have this weird formula right here. Why are we choosing this as our n, or the number of steps? So the reason we're doing 3 right here, you could read about this more thoroughly in the Think Python book, but essentially, because we have a pi involved, if we divide it by 3, it's gonna kind of take care of the kind of the rounding. So it's like, okay, it's almost 3, and we don't have to worry about the float right there that comes from the pi. This 3 right here is to ensure that we always have at least 3 sides. It just makes, when you're drawing really small, like if you have a really small r, you don't want this to go down into like 2, because if you have just n equal to 2, you'll never be able to get a polygon, because if you just draw 2 things, you'll never be able to actually close the polygon. So you need at least 3 so you can get a polygon, because what is a 2-sided polygon? A line, right? I don't know. You don't really even have a 2-sided polygon. So that's why there's the +3 there. So we'll use that same kind of function. So integer, the circumference, divided by 3 plus 3. And then everything else is really the same. The length per the side is just going to be the circumference divided by n. And then we don't want the polygon here, because again, the polygon would end up trying to close the shape. So what we're going to do is for I in range of, n, so the number of steps. And what we're going to have our turtle do is go forward some sort of, hold on, let's see what we're having right here. So we have the length per side. So I really probably shouldn't call it even a side here. So, because if we're thinking about the arc, when you think about sides, it talks about polygons, and this is really not even a good, we should really call this like something more indicative of what it is. And again, I guess we could really call this like something like step length, because we're not drawing a side. It's a circle. I mean, we know it's a side because we're approximating it, but maybe we'll update this to be more indicative of what it actually is. So that's the step length, and what we need to go ahead and do is basically know how much to turn. So this is how much the turtle's going to go forward, good old Bob. And then we're also going to need to go ahead and talk about the angle. So each step, how much angle should it turn? Well, we will need to explicitly cast something to a float. So we can go ahead and just take the angle that we're passing in. And again, if they pass in an integer, because this is Python 2, we do need to explicitly cast it to a float. So Python 3, you wouldn't need to do that. But then we can go ahead and divide that by a float of angle divided by n. So this right here, our turtle will go, it'll need to go ahead and turn. So what we were doing before, to the left, some step angle. So let's go ahead and run this with a couple of different values. So we need to go ahead and do arc, bob. How big is our, let's say radius 10. And let's say, what did you guys say? Halfway around the circle, let's say 180 degrees. Let's do arc, bob, radius 20. I don't know, what's another arc length we want to do? There you go, Patrick, sorry about that. Preference. Lots of opinions, I can tell. So let's just see if this code works and it does what we're expecting. So, interesting, not quite what we were expecting. Oh, actually it is what we were expecting. What happened there? Remember, when talking about an arc, we don't start back, we don't reset back to the original position. So this is something that I'm not going to have a whole lot of exercises this week because I do want you guys to begin working on the project this week. But remember that because we ran these back to back, it's not like the turtle automatically went back to the origin. So if we go ahead and just run one of these, and let's make this a little bit larger, let's say this is like 30, not 300, then we can see right here, there's 180 degrees, but now let's go ahead and run this one right here, the one below, with 40, something a little bit larger, and this should go 3/4 away around a circle. So we have that right there. So little subtlety when it comes to Bob here. Remember, programs only do what you tell them to do. We did not tell the turtle to go back to the start and then draw another arc. Okay, so any questions on this exercise right here? Yeah. I might know it off the top of my head, maybe not. Got error on line 57 because because it's expected function. So just put a new line and you had commented on it. Yeah. I don't know. Yeah, check that out. I don't know if ellipses was in Python 2. If not, you can always type the word pass. But yeah, basically you started to do it. So the issue was because you started to define a function, but you never gave it its body. So you have a function without a body. I guess it would be like just the head, which is kind of weird. But anyway, okay. Any questions? So one thing that I also want you to kind of get into mind, and you're going to see this as you go start working on project 2. There's certain things that are going to occur multiple different times. Notice we've done this a couple times. We have iterated from I equal 1 to 4. Let's see, we did that again here. We've done that, we did that again here. So we really did that 3 different times. So it would be nice if we could encapsulate that into its own function. And then what we can do is refactor our code with this encapsulated function. So again, this is a case study. I would definitely encourage you to read through the section and think Python, because it kind of, again, does this all in one fell swoop. So what we want to go ahead and do now is refactor it. So, like I said, this code shows up a lot. So instead of having to do that in every single time, I'm going to go ahead and refactor this. So refactoring into its own. It's like I'm drawing a polygon, but I'm not going the whole polygon. I'm just basically drawing a line. So I think the book called this a polyline. We're basically doing many lines. Let me make that a little higher for all of you. And every time we did this, we needed some turtle to do it. We considered a number of sides, n. We went ahead and considered the length of the lines, and we also considered the angle for which to turn. So if you kind of look at that, that's everything. Like this right here, we used a turtle, we used an n, which was how many times we iterated, we used some length, and we used some angle. So I could basically take this and just copy it in here. And of course, I'll have to update. So I don't want step length, I want length, and then we want angle. So right there. But that's essentially what I've been doing several times. So if I ever find a bug in my iteration, instead of having to go to the 3 different places I saw it above, I can just go ahead and adjust it right here. But of course, now this needs to be deleted, and this is technically the refactoring part. I am revisiting the code to help me understand it better by using different encapsulated functions. So I'm going to delete that. And what we have right here, whenever we were doing an arc, is really just a polyline passing in whatever turtle, again, we had already into arc. We have then also n, which again is defined above. We have step length. Let's see, what was first? Length and then angle, step angle. So that is now our arc function. And by the way, we can do this same thing. Notice this logic, all of this logic is also right here, isn't it? Like everything that we do in 51 to 55 is pretty much the same thing we do right here. Yeah?
Is it an issue that we define polyline after we use it?
So this is a great question. So when it comes to languages like Python, it will basically read the whole file, and then it'll basically realize everything that is there. So it is not an issue in Python. Now, that's not true for all languages. A language like C reads top to bottom, so if you need to you need to define something earlier in the file if you're going to use it later. So, why is it an issue on yours?
Yeah, it says polyline's not defined.
So maybe that's a Python 3 thing. So yeah, I'm a little rusty on my Python 2. I haven't used Python 2 in a few years. So okay, let me take that back. Python 3, it shouldn't matter. Python 2, you probably will need to go ahead and define polyline a little bit higher up. Okay, I'd have to look at it more closely. Like I said, I'm a little rusty on Python 2. I can show you all later too if you want to go ahead and run Python locally. Macs come with it installed. On a Windows, you could install it in like less than 2 minutes. Well, you could at least find the installer in 2 minutes. It depends on Southeastern's Wi-Fi if it'll take 2 minutes. You know what I mean? Okay. Okay, so we've refactored this. Okay, realize that a circle is just an arc with 360 degrees. So instead of repeating this, which is already down here, an arc, we can go ahead and basically our circle is just going to call arc with the turtle, but it's going to have the same radius. But we're in the circle, we're going to have our own angle and our own length to pass in. So what would that angle be? Let's go ahead and think about it. It would just be 360. So you can just do degrees in circle. So again, we have now refactored circle. And notice this right here, polygon also used this same for loop. So how would I refactor polygon? Let me give you a moment. How would you go ahead and refactor this? So to refactor this, instead of this for loop, we're just going to use a polyline, which again has those same 4 arguments. It is first going to need the turtle. It's going to need the n. It's going to need the length. And again, the angle, which was already computed, will be the 4th argument. So that's how you would draw a polygon using the polyline function. And I think that's the only one. Oh, and then technically square, we can also refactor square using a polyline. So square is just a well, actually square is a polygon, so I'm going to just make it a little more obvious. And polygon is going to have a turtle. It's going to be 4, and its length is going to be whatever length was passed in. So that is the process of refactoring. It's very weird to code because what starts out with a lot of lines, once you do some refactoring, actually becomes much smaller, but it's much more readable because now I immediately know for a square, it's just a polygon with 4 sides in length that I've passed in, instead of some sort of weird for loop that we have to kind of reason through what's happening. So that's the idea of refactoring. Nothing to do with your math class in terms of foiling and things, but it's called refactoring. So that was a little case study on functions. Any questions? All right. Of course, you should probably go back through and test all of these, make sure you didn't make any typos. But I want to go ahead and move on to the next idea, because, by the way, functions are very important. Pretty much from the rest of the course out, instead of just doing a default script, I'm going to probably write things and wrap them in functions. So just a quick review on functions, and then I want to talk about scope. So these are a couple words that I've thrown around. I just want to make sure you see them written. So functions are reusable pieces of code. Functions are not run in a program until they are called, or sometimes referred to as invoked. So if you define a function, remember that you still need at the bottom to actually call it. So like right here, if all these functions are great and all, but if I don't actually call it like I am here, Bob is just going to sit there. And it says bad input on line 60. Again, there was an indentation error here. So that right there. So now it should be better. Yeah, so nothing happened. Bob just sits there. Welcome to the life of a turtle. Sounds really good, especially on busy days. But we're not all turtles here. Okay, so a couple characteristics of functions. It has a name, which is defined after the keyword def. It has parameters, 0 or more. So again, the parameters are what are inside these parentheses in the function's definition. It has a docstring. Again, the docstring will tell us what the function does. It's optional but recommended, especially if you are going to be writing a lot of functions, especially if you're like, hey, professor is going to read this. This looks a little weird. But, maybe I should kind of let him know what I'm doing here, especially if the logic seems to misbehaving a little bit. So I will analyze your codes on your project. By the way, I'm still grading your last projects. Like I said, I will read through those codes. I just haven't had the time to go through it slowly. I've been getting the next project ready, but my goal is to do that this weekend to get those wrapped up. Anyway, it has a body. Again, that body is everything that's in here. It's indented, and it will always return something. Remember that it will always return something. If you don't have an explicit return statement, it's going to return none. So functions always return something. Proper style technically is to have 2 spaces after a function. Just throw that out there. So like this is technically bad style within the Python community because there's only 1. But anyway, we haven't talked too much about style guides. We'll get to it soon. There's a lot to learn about programming. A little overwhelming, isn't it? So take your time. Always feel free to ask questions or ask questions, and it's nice to have someone who can answer it. Okay. One thing we haven't really talked too much about functions, and again, today is to be a little bit more like a watch and think about what's happening than coding yourself. But scope is a very important thing to get your head around because have you guys encountered this? Like if you type something and it doesn't do what you're expecting it to do, the more you understand about kind of the inner workings of how language and how functions work, the better, because there's little bugs that are going to show up. So whenever you call a function, it basically creates its own little environment to work in. So and those little environments are sometimes either called frames, or it has its own, each function has its own scope. These are like little sandboxes. It's like if one function is called, it's going to only be in that one environment, one scope, one frame. So if you sometimes hear it also called stack frames, because when multiple functions are called, the frames stack on themselves. So Python Tutor, we've used it once with that exercise, but I have a couple other examples here. So let's go ahead and go to this. So this function, this is just some basic function. I just called it f of x. Let's look at what it does. F of x is going to take some formal parameter. It's going to have a y already defined to be 1 in it. Then it's going to add a y to the to the argument that was passed in. It's going to print it, and then it's going to return it. So let's go ahead and visualize the execution of this. End of file. Let's go ahead and just add that parentheses there. Okay. So let's just close that. All right. So this is going to take 13 steps to run. So first thing it's going to do is read through, and it's going to say, hey, look, this is defined right here. So if I hit next, you'll find that it has created something known as a global frame. The global frame means that every function has access to what's in the global frame. It's very dangerous to put things in the global frame from a security standpoint, but again, we're not necessarily writing like enterprise software here. We're writing scripts that help us understand mathematical ideas while learning a little bit of programming along the way. So notice that this x equal to 3 is not in a function. So in the global frame, it is going to have a value assigned to x, namely 3. In the next step, we're going to go ahead and we're going to run execute line 8. So if we look at this on line 8, we will now have y assigned a value 2 on our global frame. Now, what is z? Z is going to be assigned a value from this function that is returned. So notice now, when we go to execute line z, what happens? There is a new stack frame. This is again this is basically the environment that this function is working in. But notice this x right here is different than the x that's in the global frame. We'll talk about this a little bit more as we go, but what we're doing is we're passing by value, not passing by reference. So if we were passing by reference, changing this one would change this one. So let's see what happens. So notice now I have this y, but notice this y is different than this y. They have different values completely. But look at what happens to this x. I'm going to add to it. It updates here, but notice that this one was not changed at all, because this is a different x. So even though these two have the same name, they are different x's because they're in different frames. The next one, we'll go ahead and print. You can see that any frame can print to standard output. We're not going to deal with different input and output buffers in this course. But now we return the x and we look at what happens. Notice that this 4, right before you return it, is going to say, oh, okay, what am I going to return? Because remember, a function always returns something. And it's now going to return that. And look, this x is still 3. All of that worked with x in here. That was with its own x. And z is now assigned the value of 4. Then we can go ahead and print that x. So this is interesting because you see, notice they're both printed x, but they printed different x's. Also, notice that Python destroyed that frame when it was done. So if you ever are like, hey, I need something, and I need it to compute, you need to go ahead and store it outside of the scope. You can manipulate it and return something if you want to go ahead and use functions to modify certain variables. Then we can print y. Again, notice this y right here is different than this y that was in here. And then we can finally print z, and then that completes the code. So this is a little illustration of what a frame is, and is called, sometimes we call them stack frames because they stack on top of each other. So any questions about the execution of this program? Okay. This is a pretty easy example. Let me go ahead. I think I had one more example here. But realize that functions are just objects. Yeah, question.
Oh yeah, I'm confused because we don't actually define f of x, do we?
So we define f right here at the top. Yep.
But like, how does it know to return? Like, we don't ever say like f of x is equal to.
Yeah, we do right here. Z is the return of right here. So z is assigned the value that f is returned when it's called.
Okay, but like, how do we know what value f of x is?
It is computed in here using this logic. So this function is not, careful with thinking about it as a function like you do in algebra. Like this one technically is. This function is basically f of x is equal to x plus 1. Like that's what this is essentially the function f of x equal to x plus 1.
Okay.
But it could do more.
Because it's telling us to return x. So
it's returning, but so when you call it, whatever you call it with is bound to x when it goes into here. So when you call it with this x right here, 3's passed in, so now anything in here by default is going to think about this as this x is the one that was passed in, which was the one that was defined here.
So z equals is a call function.
So z is a variable which will store the results of the function being called. What calls the function is the parentheses. And that's where things are getting a little bit tricky as we move on, because technically functions in Python are objects. You can assign a variable to be a function. So the calling is from the parentheses. And that's what this little harder example will illustrate. So let's just walk through it briefly. And it's probably not something that you'll kind of understand the first time through. So again, I'm going to link to these so you can always go ahead and spend more time with them. But if you don't understand scope, you're going to get some really weird bugs, especially as functions become much more important and we start talking about classes and things to that effect. So again, I'll post A9. Okay, so this one, a little bit harder. There's a lot going on. So let's go ahead and just let me give you a moment to just kind of read through what is happening here. Just kind of read through it, take a minute just to kind of get in your head, and then we'll talk through some of the things that happen. All right, let's go and step through it. All right. So make this a little. So step 1. So first thing that happens is it defined f right here. So it put that function in the global frame. Next thing it's going to do is in the global frame, x is equal to 3. So you can now see x is equal to 3 there. Next step, it's going to call f, because again, this kind of goes with your question, Anna. The parentheses around x means that we took 3, which is the variable stored in x. We pass it to this function f. So here's the weird part. One function, in Python, in a function, you can define other functions that only exist in that function scope. So now when I run the next one, you can see that when I define G only exists within this stack frame. So what we could then go ahead and do is define another function h, which only exists within this stack frame, and then we can go ahead and do some sort of printing. What do you guys think x is going to print on this line? 3 or 4? It's going to print 4. It's going to print the 4 that's in the stack frame that we're currently executing in. It's not going to print 3 because, again, this 3 has not been modified yet. So it's going to go ahead and print 4. And now, this is where the stack part comes in. While we're executing f, we start executing h, which is now only in the stack frame of f. So this is the idea of it's now stacking up. And this, again, is something we're going to talk about when we talk about recursion here in probably next week or 2 weeks. But now this z executes, so you can see that this z takes the value of x, but where did this x come from? This x was not passed in. It comes from the x that was defined in the scope above it. So you can see here this 4, because this h exists within this stack, it has access to that variable. So then you can go ahead and execute that, and notice this returns nothing. So you can now see that we basically threw away that z. We did nothing with it. We just illustrated that z, that anything in that f had access to which was, or excuse me, anything in that h had access to what was an f. We can do the same thing with g, but we have to be careful right here. This x is now the one that it will go ahead and use if we did anything more with x. So basically what happened right here is this x overwrote this x. So what do you guys think is going to be printed here? ABC. It's going to take the x that is in the closest scope. If it wasn't there, it was going to check the scope above it. If it wasn't there, it would even check global scope. So it returns none. And here's one last thought. Okay, by the way, what x is going to print here? 4. That is correct, because again, we're in this one right here. And look what we're returning. We're returning g. We're returning a function. So this is going to be funny. So when we return g, the return value now basically saves that function that was created in the definition and running of f. So, okay, let me ask this now. What do y'all think z is going to print? Or what do you think this next line is going to print? Print x is equal to what? So we don't see ABC anywhere here. So that was actually destroyed. It's going to go ahead and print the 3. So notice it's going to print, so right here we're in global scope. See how this is highlighted? So it's going to look in global scope for this, this x right here. And funny part, because we returned g, this was actually not destroyed. Again, this is kind of not necessarily as important, but it just goes to show the part of like how stack frames are kind of exit and leaving, entering and leaving. Yeah, Anna.
What did it return?
We're about to see that. So it returned g and stored it in z. So we're about to print z. So we're about to see what it returned. It returned a function. And look at this right here. It's going to, so z is storing a function, and this is kind of based off of what your question was, Anna. So how do you call functions? With parentheses. So this line is about to execute g, which is stored in the variable z. So you can see right now it's executing g, and that's pretty much the conclusion of it right there. So yeah.
So because the only one that you returned was g, that was the only thing it took out and then put into the global
Scope, yeah.
The global scope, so the global scope printed z.
When the global, not quite printed, when the global scope called g, which was stored in z, it executed this g. So a lot of weird things happen when it comes to scope because you kind of have like these same names. So that's why you want to use good names. Don't always just use X, because if you have 5 X's floating around 5 different functions, you're really going to have to spend time reasoning through like, oh, this X is in global scope. So that means, crap, I just overwrote that in this scope. So it could lead to some really weird bugs. So I wanted to expose you to scope. I would definitely encourage you to go ahead and spend time with these exercises. But any other questions? Believe me, it's going to take a couple runs to understand. Yeah, question.
So I noticed, so after you defined f, it went down to x equals x plus 1, and then it didn't do h and g until you like called it and told it to?
Let's go back to the first. So we defined f. Hold on. Oh, hold on. Let me, I don't want to. Okay, so I think I have to do here. Let's see. All right, so step 1 defines f.
Yep.
Hold on, let me just refresh the page, because I think when you do Python Tutor, it will, you can use breakpoints, like run until a certain thing. So let me go ahead and reset this. Okay, so first thing, it defines f. You can now see that global frame. Step 2, it goes to x equals 3. It doesn't do this yet. It doesn't go here until you call it on line 19, which is what we do here. Then it goes back to the top of the definition, and now is in this function, now is executing f.
Wait, but doesn't it skip down to x equals x plus 1?
Now it does, because notice all these two things did was define the function. It didn't call the function until we get to line 13.
So why doesn't it call it?
Because the kind of the call operator are parentheses. So notice here, this is the definition.
Oh, right, sure. It's the same thing with like turtle. Okay.
Yeah, we're just saying, hey, this exists. You're going to probably use it later.
Gotcha.
Wow.
Okay, so yeah, that's going to definitely give you some food for thought. So, okay, any other questions? All right, let me show you a couple things about the project. Again, I'm recording this and I'll post it later, so feel free you don't need to click around. I want to show you a couple things. All right, so I have the student version of the project over here. Let me go ahead and start it. So I wanted to scare you a little bit, but I didn't want to completely freak you out, just a little. When it comes to the, like I said, hey, it took me like 4 to 5 hours to get this project ready. Now, I'm not having you do this project from scratch. I've given you some starter code because you already know how to do some things. So if you actually, when you start the project, if you could run it, it is ready to go. But all I basically have done is taken care of some of the input validation for you. And I've also kind of helped you with the structure and the flow of this program. So your part is in this section called student code. This is where you're going to do probably 80% of the project. It's just right here. You have to basically work with these functions. And if I were to go ahead and just do one, notice it says implement this function. So again, you're going to delete this right here, and you're going to have to go ahead and put the logic in. And again, this logic is defined within the project description. So I kind of demoed it to you last time. So the first part right here is to basically set up what we've already done in class, like guess it, but you do need to do some, like, hey, the computer needs to generate a random number. So make sure, I say this getting started section, and that's what we're doing right here, is just make sure you read through this code, kind of understand the logic. I would encourage you even to just go ahead and do the debugger. So you really don't, for parts 1 through 4, you won't need to change any of this starter code. Like, here's the function that prints the banner. Here's the function that does the asks you for the game mode. Here's the function that basically, let's see, what's this function? Yeah, so this one is basically the game mode. This one is, okay, once you've selected, is handling the selection of the mode. This is basically is defining like the easy, medium, hard. So these are ones that you'll go ahead and, I was already taking care of you. It basically gets the game set up. So you just have to implement the logic of the different modes. Still read through it, because part 5, you're going to have to adjust some of these, and I ask you to document that. Yeah, Anna.
What's the arrow?
So what's the what arrow? Right here.
127.
On line 127. All right. Yep, that's what I'm going to go ahead and that's what I'm going to talk about next. So again, this is the replay because again, as you complete the game, you want to go ahead and kind of be able to ask them if they want to play again. So a couple of constructs here. There's a lot happening. So definitely read through this, understand. There's a convention within Python programs that there's this weird line at the end that says if underscore underscore name underscore underscore is equal to main, call this function. So this is basically all of this above, if you notice, was just me defining functions. I haven't done any sort of action. Okay, actually I lied. I did do a little bit with this. I've defined some constants that you might want to use, and I've also imported some utility functions that I wrote for you. So the first thing it's going to do, if this is the main file, it will call main. The main function will go to here, print the banner, set play again equal to true, and then start a loop. Basically, once the game is completed, it'll go ahead and return some value, and it will, if it was false, you say, I don't want to play again, it will go ahead and just say, thanks for playing, program ends. But if you do say true, it's going to basically recall the play game and reset you back to the beginning to select options and things. So the question was, what does this arrow mean? So in Python 3, there's something known as type hinting. So in type hinting helps you understand what a function does. So before, what we would do is we would just basically write, I'm going to just delete it, but so up to this point, we've done basically this. We just given it a prompt. But what is prompt? Maybe you want to make sure that that prompt is a string, so what you can do is say :data type. So this says this function will take some prompt, and you're telling whoever's using this function that prompt should be a string. So basically that means that it's going to throw up an error if you try to use a float or an int and say, hey, you're not using this function correctly. It's a way to protect you from, like, if you're like writing a lot of functions, like, okay, I know that my input has to be a string. This arrow tells you what this function is going to return. So there's no guessing like, oh, does this function return a bool? Does it return a float? Does it return an int? Well, it returns an int. So this validated input, by the way, remember in chapter 1 where you were checking like, oh, did the user enter a proper string? Did it enter a proper float? Don't use the input function. Use the validated input function, because basically what this is going to do, I have written it to wrap around the input function that is going to continually prompt the user until a positive integer is inputted. So you don't have to handle any of those corner cases. I've kind of basically said, go ahead and nag the user until they behave. I set that up for you using this try except clause. So I would encourage you to, of course, play with this and understand it. I've also done something similar with a get random positive int. It is going to, it has a default parameter of a million, and it's going to return an int. And basically, I'm just making sure I'm wrapping this function so you don't have to worry about imports and things. I'm handling that in the utils function. Last thing I'm going to go ahead and say, we're doing a lot of random number generation. In random number generation, there's a concept known as seed. Basically, a seed will there's no such thing in computers as something that's truly random. Basically, I mean, you think of it, there's some algorithm that's generating a sequence of numbers. By default, it will seed with usually some information that's completely blind to you. Some like really fancy, like high-end security will seed with the temperature of the CPU, like down. So like it's like there's no way it can be created because it's using some outsourced source. I am seeding it with the number 1. So every time you call a random number, it's going to start by giving you, like I think it's in the project description. It's going to every time give you 140,892 because I have seeded the random number generator by default with the number 1. If you want to try different numbers, of course, you're free to go in here and edit the seed, but of course, when I'm grading, I'm going to make sure I'm using a seed of 1 because I don't want to have to run your program 12 times and figure out, I don't want it to be random when I'm grading. I want it to have some consistent behavior.
So a different seed.
So if you change the seed here to 2, it will generate a sequence of random numbers, always starting with the same 1. So it's technically random number generators in computers are referred to as pseudo-random number generators. So this gets into a philosophical debate about like, is there anything that's truly random? Definitely not in computers because it does rely on some sort of seeded value. So spend some time with this. These functions are here to help you. Feel free to use them. And like I said, parts 1 through 4, you're going to implement here. Part 5 is a choose your own adventure, where I have given you some suggestions. Stick to these suggestions. They're not too outrageous. If you have some grand idea and you feel like you're like, hey, I really want to try this. Is it similar in scope? Well, feel free to propose it to me, but I feel like these are some good starting ones because it's always interesting to, as you write programs, think about how can you extend the functionality. So if you want to implement all 4 of these, well, you're welcome to as a bonus. So the bonus is basically implement all 4 of these. Part 5 is pick 1. So that is the project. Definitely spend some time with it sooner rather than later, because like I said, no pun on scope. There's definitely a lot more going on in this project compared to the first one. If you have questions, let me know. Otherwise, have a fantastic day, and we will pick up on Friday with, I don't know, I have like 3 ideas. Haven't decided yet. We'll find out on Friday. Have a great day, everyone.